The sketch shows a typical turbocharger fitted in large slow-speed engines. The main parts are the turbine rotor with blades and the impeller mounted on a common shaft enclosed in a volute casing. The exhaust gas enters the water-cooled turbine casing through a grid which prevents any broken pieces of piston ring from entering the turbine. The exhaust gas passes through nozzles where the pressure energy is converted to kinetic energy. The gas impinges upon the turbine blades, rotates the turbine wheel and comes out of the exhaust gas outlet. At the blower end, the impeller draws air from the engine room atmosphere through the silencer air filter. The air inlet passage is called inducer. It guides the air smoothly to the impeller. Impeller discharges the air radially through diffuser and volute casing to the air cooler. The diffuser and volute casing have divergent shape which reduce the speed of air passing through them. This reduction in speed converts kinetic energy into pressure energy. The turbine casing is water-cooled, but in some designs, casing is air-cooled. The rotating parts are supported on spring-mounted ball bearings at the ends. Turbine-driven pumps lubricate the turbochargers. There are two pumps, one on blower side and the other on turbine side. The pumps direct the oil to the bearings. Labyrinth glands prevent leakage of air and exhaust gas. On the exhaust gas side, the labyrinth gland is supplied with sealing air under slight pressure from the blower. This prevents exhaust gas from escaping to the oil space. The sketch shows Sulzer RTS series engine scavenging system. The piston is shown at top dead center. During the downward stroke of the piston, when the crank is about 95 degrees past the top dead center, the exhaust valve begins to open. When the crank is about 50 degrees before the bottom dead center, the scavenge ports begin to open. They are closed when the crank is about 50 degrees past the bottom dead center. The exhaust valve closes about 70 degrees past the bottom dead center. The exhaust gas passes through the turbine side of the turbocharger via the cylinder exhaust valve and exhaust gas manifold. The exhaust gas drives the turbine. It also passes through the economizer where it is used to convert the feed water into steam. The turbine is connected to a centrifugal blower. The rotation of the turbine rotates the blower. The blower rotation causes air from the engine room to pass through an air filter, cooler, water separator and deliver to the scavenge air receiver. The scavenge air receiver has an inner and outer compartment with a set of non-return valves between them. From the outer compartment, air enters the inner compartment. From the inner compartment, the scavenge air enters the cylinders when the piston uncovers the scavenge ports towards the end of its downward stroke. An electric motor drives the auxiliary blower. During maneuvering, auxiliary blower draws air from the outer compartment and delivers to the inner compartment via another set of non-return valves. The operation of the blower is automatic. The blower starts whenever the scavenge air pressure drops below a preset limit. It stops automatically when the pressure is sufficient. If the turbocharger breaks down, the auxiliary blower delivers sufficient air to run the engine at reduced power to reach the next spot.